So in this video from today, we're looking at the practical, the nitration of methyl benzoate. So it's important in this practical that you control the temperature. If the temperature is too low, the reaction won't occur, it'll be too slow. However, if the reaction gets too hot, you run the risk of getting multiple substitutions. So this practical is all about controlling the temperature by adding your nitrating mixture slowly and by cooling it in an ice bath. So in this practical, you're going to weigh out a small amount of methyl benzoate. You're going to dissolve that in concentrated sulfuric acid and cooling that in an ice bath. Generally speaking, we will usually prepare the nitrating mixture for you because that takes quite a long time to get it cool enough. Then, the difficult bits. You need to add the nitrating mixture dropwise, keeping the mixture in the ice bath. So we're trying to keep the temperature below 10 degrees Celsius. Going up to 15 is fine, but going over 20, we're likely to risk multiple nitrations. Once you've added all of your nitrating mixture, you let it stand for a small amount of time and then pour the reaction mixture onto the crushed ice. Now what that will do is it will destroy the catalyst. So it'll dilute the sulfuric acid enough so that it'll no longer work as a catalyst. You can then filter your crystals using a Buchner flask and funnel, which looks like one of these, and wash them with cold water to remove any acid impurities. At this point, you're going to have crude crystals of methyl 3-nitrobenzoate. To obtain pure crystals, you need to recrystallize them. So recrystallization is an important process that's used in organic chemistry to turn crude crystals into pure crystals. It's a way of removing both soluble and insoluble impurities. So the first thing we are going to do is we're going to take our crude crystals and add a minimum amount of solvent, where they're going to warm to dissolve. Now quite often you can combine these stages and say add a minimum volume of hot solvent. So our crystals will dissolve, but any insoluble impurities will be left behind. The next stage needs to be done quickly, and we do a quick hot filtration. So that will leave behind the insoluble impurities. So they will stay on the filter paper and we will collect the filtrate. We'll then allow our substance to cool. Now as it cools, our crystals, our pure crystals, will crystallize out, and this will leave the soluble impurities back in solution. At this point we can then filter off our crystals, rinse them with a little bit of ice cold solvent, and then very importantly dry them so they've got no solvent left. The solvent choice is also important. We choose a solvent such that our crystals are soluble in hot solvent but insoluble in cold solvent. So the choice of solvent is very important in this case. This is our starting material, methyl benzoate. And what I'm trying to do is I'm trying to nitrate this compound. So there's my reaction for making my nitromethyl benzoate. I've added a nitro group onto my benzene ring. So there are two procedures that help prevent the further nitration. One is keeping that temperature well below room temperature. We've said roughly about 10 to 15 degrees Celsius. Secondly, we add the nitrating mixture dropwise. However, if the temperature rises too far, we're likely to get some di or even tri-substituted. So we can get methyl 1,3-dinitrobenzene. We wash the crystals with water to remove the acid impurities. We're trying to keep our loss of product to a minimum during recrystallization, so we use the minimum volume of hot solvent. So we can do our calculations based on our limiting reagent, which is our methyl benzoate, And our theoretical yield, therefore, would be 3.62 grams of methyl 3-nitrobenzoate. There are quite a lot of hazards which are posed by this preparation. So firstly, you're using concentrated sulfuric and concentrated nitric acids. Both of those are corrosive and cause burns on contact with the skin. So when you're adding the nitrating mixture dropwise, it's useful to be wearing gloves. Hot ethanol is flammable, so trying to heat that can be quite challenging, and that's why we do that usually in a water bath. Finally, the purity of the product can be checked by doing a melting point analysis. So we want the melting point of our pure crystals to be sharp and to be within a few degrees of the accepted values. And we're going to be looking at melting point determination in a later topic. So that just finishes this little video looking at the nitration of methyl benzoate. In the next videos, we're going to be going back and looking again at the mechanisms for these reactions, electrophilic substitution. So until then, take care, stay safe, bye bye.